Welcome to this video in which we briefly discuss how to measure voltage, current, and resistance using a multimeter. I have on the screen a picture of a typical multimeter. This is in no way meant to be an endorsement of this particular brand of multimeters, but it is a multimeter. It has a couple of useful attributes. One is the display. You can see that the display shows, in this case, I think a measurement of voltage. It has the dial which selects what you're measuring. You'll notice right now that we're pointed at the V, which stands for measuring voltages in the 1 to probably 100 volt range. I could also take this dial and point it at MV if I wanted to make accurate millivolt measurements. This multimeter will also measure current if I point it to A. And if I want to measure current, then I need to take this lead and move it over to here. I can also measure milliamps, and again I'd have to take the red lead and move it over to here. Not all multimeters anymore require you to do this. Some of them will just have the black lead will always be there. It's called the common lead, and then you'll just have one plug where you use to measure voltage and current. But older multimeters have 2 or 3 leads. Over here we have what we call the probes. These, well, actually this point here, that's the probe tip. These are the things that you touch to your circuit in order to figure out what a voltage or a current is, or to measure a resistance. This meter will measure resistance. You can see that with the ohm sign. You would turn the dial to measure resistance. So let's see how we might use this to measure voltage. Okay, I've now added a circuit, and let's suppose we want to measure the voltage across this particular resistor. Well, I would set my meter so that it's pointing towards the voltage, and then I take my probes and I would have my red probe connect to one side of the resistor and the black probe connect to the other side of the resistor. Hopefully you'll remember that voltage is something you measure across things. So I need to have a probe connected to one side and a probe connected to the other side of the thing I'm measuring the voltage across. And then I just hold it there. The numbers will change for a bit as it settles down, and then you've got the voltage across the resistor. That's not so hard, is it? That's measuring resistance. Now, or I'm sorry, that's measuring voltage. Okay, so I can also measure current. Now, you'll notice that in my picture here, I've taken the red lead, which was over here on the voltage terminal, and moved it over here to the current terminal. Hopefully when you do it, you won't leave a big black hole in your meter. And then I connect the red terminal, or the red probe, to a point that I want to measure the current going through, and the black probe to the other side of the point that I want to measure the current going through. Now, in order to measure current, that current actually has to flow through the meter. So in other words, the path that I need my current to take is to flow through the red probe, up here into the meter where the meter does its thing, and back out the black probe, and then through the rest of the circuit that I'm interested in. Now, in order for this to do this, I need to make sure that there's no connection in the circuit between the red probe here and the black probe here. And you can see, hopefully, the way I've got this picture, right here, there's a wire that's part of the resistor lead that connects from here to here. In order to measure current, I have to cut this wire. I have to break the connection. so that the current then will flow through the red lead, again through the multimeter, and back out the black lead, and then through the resistor that I'm measuring the current through. Now this, in some situations, is not bad, but if I've got a circuit board that I've put together and all of a sudden I have to go cutting things to measure currents, it's obviously not good. One alternative is if I have a resistor whose value I know, would be to measure the voltage across the resistor and then compute the current flowing through the resistor using Ohm's law. Okay, so that's measuring current. To measure resistance, I'll go back to the situation where I have a circuit that has a resistor in it, and I want to measure the resistance across this resistor. Well, what I would do is I would take the meter, take the dial and set it to resistance, and then touch the probe across each point in the resistor. Okay, resistance is something that you measure by touching the two probes to the opposite ends of the resistor. Now, the way I've drawn it here is actually misleading in the sense that this probably isn't going to give you the resistance that you want to find. What happens when the multimeter is measuring resistance is it sends a known current through the resistor. Well, I guess it'd probably go this direction. And then it measures the voltage generated by this known current. Now this has some implications. And then it uses Ohm's law to figure out what the resistance is. If you've got a known current and a known voltage, then from that you can compute the resistance. But this has a couple of implications. One, if this resistor is connected to anything else in the circuit, say these guys out here, or these big capacitors or stuff, then you will be putting a voltage across all of the component. Well, you'll be putting a voltage not only across this resistor, but across any of the other components that are connected to it in parallel. And so what will happen is you'll probably be finding not the resistance of the resistor you're interested in, this guy, but maybe the resistance of a parallel combination of things or something. You don't know for sure if the resistor is embedded in a circuit, what resistance you're actually measuring. Another thing that this means is that you cannot measure the resistance of a resistor when the circuit is powered, because the voltmeter is going to be applying currents and voltages. If the circuit is powered, there may be other currents and voltages that show up, and so your measurement of resistance will be futile. It won't work. This, for example, turns out to be an issue if you want to measure the resistance of a light bulb. An incandescent light bulb operates at about 2,000 degrees centigrade, something like that, a fairly high temperature. And its filament is tungsten, and it turns out that when tungsten is hot, its resistance changes dramatically. So if you connect the two probes to a cold light bulb, that is a light bulb that's not in the circuit, you'll measure a fairly low resistance. You'd want to measure the resistance of the light bulb as it's in the circuit, as it's powered, because again, when you power the light bulb, its resistance changes, but you can't do that with a multimeter because you can't measure powered elements. So there are some interesting things that happen. So hopefully this has been helpful. This is how you measure voltage, current, and resistance with a multimeter.